All right, so our goal today is to solve inequalities, and we are going to touch on what set builder notation is, just so that we kind of know it when we see it, but it's not something that our goal is that you can solve linear inequalities. So instead of it being equal, we're going to have a greater than or less than sign. So we're going to look at solving one-step inequalities, and then looking at solving multi-step inequalities. Set builder notation is that usually sometimes you'll see it written where we define our variable, so we might define it as x, and then we define the restrictions on the variable. So such that, that's what this line means, is such that. And then we say, oh, it's x is greater than or equal to 3. So that's my variable is defined as x, and these are the restrictions, so such that x is greater than or equal to 3. So I'm going to do this in set builder notations, not something that's required as part of this unit or this lesson, because we're really just wanting to go back over the inequalities, but I'm going to write it all in that. So when you see that, that's what I'm doing. Rules that we're going to talk about is that the addition property and subtraction property. So just like equalities, I can add something to both sides. It doesn't change the inequality. If it's a is greater than b, then when I add c to both sides, it's still a plus c is going to also be greater than b plus c. Same thing with less than, and also negative. So if I subtract the same number from both sides, it's still going to be the true inequality. So here I have 4y minus 3 is less than or equal to 5y plus 2. So I'm going to move this 4y over with this 5y because it's smaller. So I'm going to subtract it because it's positive. So then I have negative 3 is less than or equal to y plus 2. Now I'm going to move this 2 over here, so it's a positive, so I'm going to subtract it. So I have negative 5 is less than or equal to y. So we want to write our inequalities as the variable first. So since negative 5 is less than y, then y is greater than negative 5. Notice it's still facing towards, the open part is facing towards the y. So in set builder notation, my variable is y that we have here, in the such that y is greater than negative 5. So your graph of the solution is also part of your answer. So I want to graph the numbers that are less than negative 5 but not equal to negative 5. So I'm going to put an open circle because negative 5.1 is less than, or is actually the number is greater than negative 5. Negative 4.999 is greater than negative 5, but it is not negative 5. It's included, so I'm going to put an open circle to show I'm not including negative 5, but I'm including everything near it. And then it's greater than, so the numbers greater than negative 5 are to the right. Greater than are to the right when written this way, and less than is to the left. Open circle because it's not equal to it. So go ahead and pause the video and work this one out, and then start it up and check to see if you have the same answer. And you should have gotten A. Right, so then we're going to look at two more properties, is adding and subtracting, because we know with equalities we are multiplying and dividing, and the rule with multiplying and dividing is whenever we divide or multiply by a negative, we actually flip our inequality. So here this was positive, but if I look here, when I divide both sides by c and c is negative, then my inequality went from greater than to less than, and from less than to greater than. Same thing with multiplying. If I multiply by a negative, then I flip my sign. So that should be one thing we think of right away. Multiply or divide by a negative. Flip the inequality. Right, so let's look at some here. So I have 12 is greater than or equal to negative 0.03p. So I need to unattach this multiplication with division. So I'm going to divide by negative 0.03. And I'm going to get negative 40 is greater than or equal to p. Again, I want to write it with the variable first. So p is less than or equal to, mouth is opening to the negative 40, still needs to be when I rewrite it. What am I doing? So then I divided by negative, so I need to flip this sign because I divided by a negative. Now I'm going to rewrite it with the variable first. So p is greater than or equal to negative 40 because I flipped that sign. So set builder notation is p's such that p is greater than or equal to negative 40. On my number line, I have negative 40. Don't need to go a ton around it, but I'm going to include negative 40 this time. So I'm going to put a closed circle at negative 40, and I want everything greater than, so everything to the right of negative 40 is going to be my graph. So I'm going to show an arrow that it's going to continue to go right. So try this one and then check it. Now let's look at when we have a couple steps. So here, I want to move this 2, unattach that 2 first because I can't move these because it is all divided by 2. So I'm going to multiply both sides by 2. Don't change my inequality because I didn't multiply by negative 2. Then I'm going to move this x over. It is a positive x, so I'm going to put it with these x's. So I'm going to subtract it. So I get negative 3x is greater than negative 7. Then I'm going to divide by negative 3. Since I divided by negative, I should remember to flip my inequality. So then I have x is less than 7/3. Set builder notation. So I'm going to put an open circle at, my goodness. So that is 2 1/3. So here we have 2, 3. I'm going to put an open circle at 7/3. And arrow is going to the left because it's less than. Alright, so I'm going to have you look at those. We won't look at this today, but if you want to go through the PowerPoint and look at it, you sure can. But our lesson is mostly on just solving those inequalities for the way they are. So you're going to go to Delta Math and work on solving those inequalities.